Hello everyone. In this video, let's take a look at two geometric problems. Problem number 1. In triangle ABC, AD bisects angle BAC. Find the value of angle BAC if 1 over AD equals 1 over AB plus 1 over AC. My thinkings to this problem includes, first of all, I need to establish a relationship between the angle BAC and AB, AC, and AD. And second, I know there is cosine law to link side length and angles, which I can apply. And third, I know AD is an angle bisector, and there is angle bisector theorem that I can make use of. Okay, let's get started. To simplify my writing, I'm going to use B, C, D, and theta to represent sides AC, AB, and AD, and the two half angles of BAC. Then 1 over AD equals 1 over AB plus 1 over AC leads to 1 over D equals 1 over C plus 1 over B, which further leads to D equals BC over B plus C. I'm leaving this here for now. And since I need to have some relationship between CD and theta and BD and theta, I decide to apply the cosine law on both triangles ABD and ACD. And in detail, BD squared equals C squared plus D squared minus 2CD cosine theta, and CD squared equals B squared plus D squared minus 2BD cosine theta. Note that in those two equations, the life sides are BD and CD. Since I know AD is the angle bisector, I can apply the angle bisector theorem here, which is BD over CD equals AB over AC. And since in the cosine law, the life sides are BD squared and CD squared, I'm going to take the squared on both sides of this equation, which leads to BD squared over CD squared equals AB squared over AC squared. And in this equation, we can plug the expressions of BD squared and CD squared, and also AB equals to C, AC equals to B. Then this equation can be written in this new format. And both sides of this new equation can be multiplied by their common denominator here, which leads to a new equation here. Note that on both sides of this new equation, there are terms B squared and C squared. That means it can be cancelled out. After that, I also notice that both sides have the common factor D, so it can be cancelled out too. Then this equation leads to C squared times D minus 2B cosine theta equals B squared times D minus 2C cosine theta. Then I'm going to move the terms that contains cosine theta to one side and the terms containing D to the other side. It becomes this new format. And I note that both sides can be further factorized. Then it leads to the following equation: 2BC cosine theta times B minus C equals B plus C times B minus C times D. Let's see what we can do to this new equation. There are two scenarios that I need to discuss. First of all, if B is not equal to C, then in this equation, the common terms B minus C can be cancelled out from both sides, which leads to 2BC cosine theta equals b plus c times d. Then I can apply the expression of d into this equation, which leads to this following format of the equation. Note that in this equation, b plus c can be cancelled out, and bc can be cancelled out too. Then we can get cosine theta equals 1 over 2. Since theta is an acute angle, that means theta equals 60 degrees. This is the first situation. The second situation, b equals c. Then, first of all, I'm going to apply this into the expression of d, which leads to d equals c squared over 2c equals c over 2. And also from the fact that b equals c, I know triangle ABC is an isosceles triangle, which leads to the fact that AD is perpendicular to BC, since AD is an angle bisector, which also means angle ADB is a right triangle. So in this right triangle, cosine theta here equals d over c equals 1 over 2, since d equals c over 2. And from here, theta equals 60 degrees, which is the same as we got in the scenario 1. That means in both situations, angle BAC, which equals 2 theta, equals 120 degrees. This problem gets solved. Problem number 2. ABCD is a parallelogram. AB squared minus BC squared equals M, and the two diagonals AC times BD equals N. What's the area of this parallelogram? My thinking to this question is, first of all, I need to establish a relationship between ACBD and ABBC or ABAD. Second, I need to link the area to AB and BC, or AB and AD. Let's get started. First of all, to simplify my writing, I'm going to use A and B to represent the two sides of this parallelogram, and theta to represent the acute angle of this parallelogram. I need to establish a relationship between the two diagonals and the sides of this parallelogram. Then I'm going to apply the cosine law here. In detail, BD squared equals A squared plus B squared minus 2AB cosine theta, and AC squared equals A squared plus B squared plus 2AB cosine theta. Note that in the expression of AC squared, there is plus sign in front of the cosine term. That's because angle ABC equals 180 degrees minus theta. The problem gave us the expression of AC times BD. I note that we have AC squared and BD squared here. Then I'm going to calculate AC squared times BD squared, which is equal to this form. And I note in this form, I can apply the square difference formula, which leads to A squared plus B squared then squared minus 2AB cosine theta then squared. The problem gave us the expression of A squared minus B squared, but I have a squared plus b squared here. Well, I can do some manipulation. It becomes a squared minus b squared then squared plus 4a squared b squared minus 4a squared b squared cosine theta squared. The last two terms have the common factor 4a squared b squared, and the rest becomes 1 minus cosine theta squared, which equals sine theta squared. The entire expression becomes a squared minus b squared then squared plus 4a squared b squared sine theta squared. And of course, the latter can be written as ab sine theta then squared. And note, ab sine theta equals the area of this parallelogram. And a squared minus b squared equals m squared. And ac squared times bd squared equals n squared. That's great. This expression can be further written as n squared equals m squared plus 4s squared. And finally, s equals the square root of n squared minus m squared then over 2. This problem gets solved. So, a brief summary of today's lecture. The cosine law is a very effective way to establish the quantitative relationship between the side length and angles in a triangle, especially if the triangle is not special. Thank you.